Oh, it's a...
Make sure you read about it tonight. We sent spacecraft that orbited Mercury. Do you remember the name of the spacecraft that orbited Mercury? Messenger.
Oh yeah, Mercury Messenger.
Messenger.
Can we turn off the lights?
And that's a look at what the Messenger spacecraft looked like. Went around Mercury a few times, many times, orbited it, got an orbit around it. So it just went around and around and around. Took pictures and all sorts of stuff. Mercury looks kind of like our moon.
Looks like the Death Star.
Mercury doesn't have an atmosphere. The atmosphere and the planet, here's the deal with planets. If they're big, they've got a lot of gravity, and that'll hold in an atmosphere. If they're small, they don't have much gravity, and gases just go off into space. Gases are molecules that are moving very fast, and you have to have a lot of gravity to keep those near the planet. And so any kind of small object, the gases tend to escape from, and so there's no atmosphere, like our moon. Mercury is bigger than our moon, but it still doesn't, it's not big enough to really hold an atmosphere. So it doesn't really have much of an atmosphere to speak of. There's a little bit of helium around it that comes up out of the planet, and then it eventually goes off into space. It stays around it for a little bit. So there's a very, very thin atmosphere of helium, but basically not. Also, the hotter it is, the faster the molecules move, and the more it makes them want to leave, or able to leave the planet. So Mercury, being so close to the sun, is so hot that any gases around it would have so much energy that they'd fly up into space. So that's two reasons Mercury can't really hang on to an atmosphere very easily. It's hot, and it's not very big. So it's kind of like the moon, because it doesn't have an atmosphere. Anytime an asteroid hits it, it leaves a crater, and the crater doesn't erode, and so it's full of craters. Craters all over. They've named some of them. Willis Crater. There's Willis Crater right there. I just made that up. Yeah.
When the astronauts went to the moon,
Yeah.
did they walk around, like, I mean, obviously not the whole thing, right?
Just a small area. One of the missions took a rover with them, which is like a little car that you can drive around.
Oh, they drove around?
And they drove around, yeah. Isn't that cool?
Like, are those craters?
They're huge.
Okay. Like, did
So,
they walk in
like,
them?
I'm not sure the scale. This picture doesn't have anything on the scale. So, these craters could be really big. Like, they could be miles wide.
Wow.
So, if you landed, you wouldn't be able to get very far away from your spacecraft.
Oh, okay.
Unless you had a rover, which they did at one time, and they drove it around and got to see more.
How heavy was it? I feel like it'd be like floating.
It's pretty heavy. It was like well, remember the gravity on the moon's only 1/6.
Yeah, what
So-
if you jumped like really high and just started floating away?
Just flew.
Yeah.
I guess you could. There's video of it riding around on the moon there. We'll take a look at it. Look at that giant impact there. That's called the Calorus Basin, I think. No?
Yes.
Is it?
Yes.
Okay. It's a very big crater.
It's 1,000 miles wide.
Oh my
1,000 miles.
No.
So from there to there is the same as
That is
like the
right.
state of Georgia. Bigger than state, twice the size of the state of Georgia.
Sweet.
Big crater. There's a bunch of ejecta around this thing. You can't really see it from this picture. This right here, you see this crack right here?
Yeah.
There's cracks like that going over the entire surface of Mercury. And where's my little moon globe? Yes, thank you. So Mercury looks kind of like the moon. And they think that when Mercury was young, it was real hot, and when something's warm, it expands, and when something's cool, it contracts. Y'all heard of that before?
Yes.
So they think when Mercury was real young, it was big and hot, and it was bigger, and then as it cooled, it got smaller, And if you can imagine the whole crust of the planet, if the whole planet's getting smaller and the crust is solid, all of a sudden there was a crack. And imagine, so my fingers like this, imagine if I made them smaller, it would go. And you would be left with one part of the crust over the other part of the crust. And that area right there where my fingers are is a big ledge, like a big mountain. And so this part's high, and then it goes down, and the next part's lower. And we call that a scarp. And that's it right there, that's a scarp. So early in the formation of the moon, formation of Mercury, that scarp formed.
It looks like a big plateau.
That is a big ledge, like a cliff.
Oh wow.
Like if you're a little astronaut, you could be standing on the edge of it, and that would be way down. So it's like the Grand Canyon down there. It's like goes way down. But it's not a canyon because it's half the planet. Imagine if and there's the ledge right there. Does that make sense? And what do you call that?
Scarp.
A scarp. They only see that on Mercury, though, for some reason. It doesn't happen everywhere. Mercury's got a cray-cray rotation, y'all. Mercury's rotation is really weird. Do they still say cray-cray?
I don't know.
Yeah,
You do.
very few.
No, it's going into Saturday.
We're gonna get got. So these arrows show where a spot on Mercury would be over time. Mercury has this kind of backwards looping rotation, which is hard to understand unless you see a video. So check this out. Look how Mercury spins. Now follow the arrow that's pointing towards. It's actually spinning.
So wait, I see.
It hurts my head.
That's silly.
Wait, what?
It's going
Can you
like
follow it?
a smaller circle around the circle.
So here would be it'd be daytime. It's still daytime. Whoops. Let's redo it.
In this video, we will watch Mercury as it revolves around the Sun. We will also notice its motion as it rotates around its own axis. Mercury has a very interesting characteristic. The time it takes to rotate once about its axis is exactly 2/3 of the time it takes to revolve around the Sun. In other words, by the time we see Mercury go around the Sun 2/3 of a revolution, the arrow shown
Chris,
here
how's good? How's this make you feel?
It's great. I love the birds.
Hold on. Let's try this again.
Hi viewers.
Very
We're
good.
learning astronomy.
Okay. So. Oh, now you can't see anything.
No.
By the time it comes on, the video's gonna be done again.
Wow.
Oh,
Well, it's 9:05.
Start getting up and dance.
okay, I know this. Ready?
I thought you were about to start doing another dance.
Oh, I know what dance you're talking about. We don't speak of that time.
Hey, you're the one who wanted to do it.
Oh,
Did you?
Oh, here we go.
I did it.
Oh, I didn't see it.
You didn't see it? I'm here.
Okay, I got
They
it.
were in the
All
locker
right,
room.
let's watch it again.
Our whole grade didn't see it.
I wasn't embarrassed, but I got some compliments on this.
Hey, I didn't see it.
I wasn't
didn't see it.
embarrassed. You're like,
Here it
yeah, you
is.
did good. I was like,
Watch it now. So, if you follow the arrow is, okay, it's pointing away from the sun, so if you're at the arrow, it'd be night. Now it's day. Now it's day. Now it's night. Now it's day. See what I'm saying? Now it's night.
How often does
Oh,
day and
what?
night, like what's that?
Like, one whole year is
Yeah,
88
so
Earth
a
days.
year
Is 88 Earth days.
takes 88 days to go. It takes 88 days to go around the sun once. But it takes 2/3 of that time. What's 2/3 of 88?
57.
60.
It takes 57 days to spin around on its axis once.
That's,
So hold on, let me back this up. It's a crazy orbit. So let's see how long it takes to go around once. Okay, so here we are pointed at the sun. And here we are finally pointed at the sun again. Now that's from noon to noon. Let's see that again.
boom.
There we are pointed at the sun, so that would be like noon on Mercury. So count how many times it goes around from that till the next noon. One time around.
Boom.
So a
Two
year.
times around till you reach the next noon.
So a year on Mercury, according to Mercury days, it's like a day and a half.
Right.
A year?
2 years is 1 day. Now, so it takes 2 times around to get from noon to the next noon. But how many times does it take just to circle once? So, you see the direction this thing is pointing, right?
Yeah.
Let's see how long it takes to go around till it's pointing that same direction.
So, one.
Bam. Whoops. Back that up a little.
Back that
Okay,
up
so
a
this
lot.
is point. Let's get it where it's pointing. It's hard to stop this.